Happy morning, students. I am Supriya, your physical science teacher. Today, we are going to learn about motion and its related aspects such as displacement, speed, etc. Motion, it forms an integral part of our life. All particles in the universe undergoes some kind of motion. All microscopic and macroscopic objects in the universe shows movement. When an object is moving, we say that the object is under motion. The moving object changes its place with respect to time or any other reference point, then we can say the object is in movement. If the object does not changes its position with respect to time, then we say that the object is at rest. So, motion and rest are relative terms. Motion is separately a absolute term. There are many types of motion as we have already learnt in class 6 itself. A few among them are rectilinear motion, periodic motion, rotatory motion, curvilinear motion, oscillatory motion, etc. Let's discuss motion along a straight line. The simplest type of motion is motion in a straight line. Consider two positions A and B separated by 140 km as shown in the figure. If a person travels from A to B, covers 140 km and come back again from B to A, covering the distance of 140 km. The total distance covered by that traveler is AB plus BA, altogether 280 km. So, we can define distance as the actual length of the path covered by a moving body irrespective of its direction. The distance is always positive. The distance covered by a moving body is never zero. Remember, we can define distance as the actual length of the path covered by a moving body irrespective of its direction. The shortest distance between the initial position of a body to its final position is called as displacement. For example, a cyclist is moving from A to B, covers 4 meters and crossing 3 meters distance back to reach C. The distance covered from A to C is AB plus BC, which is equal to 7 meters, whereas the displacement is 5 meters from A to C. This we can calculate using the Pythagorean theorem, that is hypotenuse square is equal to sum of the square of the other two sides. So AC squared is equal to AB square plus BC squared results 5 meters. If the body reaches back to its initial position, then the displacement of the body is 0. This happens when an athlete takes an round of circular field of radius, or if he completes one round, his displacement is 0 as he reached his initial position. So, when he takes a complete round of one round, he reaches his initial position. Even though he covered the distance of circumference, the displacement of his is 0. It's time to recall vector and scalar quantity. If a quantity possesses only magnitude and no specific direction, then it is said to be scalar quantity. If an object possesses both magnitude and direction, then it is said to be vector quantity. For example, distance is a scalar quantity, displacement is a vector quantity. And remember, distance of a body cannot be 0 and the displacement of a body can be 0. Remember these two important aspects. Let's discuss about uniform and non-uniform motion. In uniform motion, an object covers equal distances in equal intervals of time. Now, if we plot the graph between distance and time, take time in x-axis and distance in y-axis. If you plot the graph results in a straight line with a positive slope. Once again, the graph gives a straight line. In a non-uniform motion, an object covers unequal distance in equal time interval or vice versa. Vice versa means it is covering equal distances in unequal time interval. If we plot the graph resulted with a curved line. Different objects may take different time to cover a given distances. For example, the distance of 5 km covered in various time interval by different travelers like a pedestrian, a cyclist or by a motorist. Measuring this rate of motion of an object is to find out the distance traveled by the object in unit time. To observe and experience the speed of the automobile, we are using the unit of kilometer per hour. In automobile, a device called speedometer is fitted to measure the speed at each instant or moment of time. This speed is termed as an instantaneous speed. SI unit of speed is meter per second. In most of the cases, speed of an object is in non-uniform motion. For example, if you are traveling in a busy road with many signals in peak hour, we describe the rate of motion of such object in terms of their average speed. Average speed is calculated by the total distance covered by the total time taken of the object. Average speed is calculated by total distance to the total time taken by the object. The rate of motion of an object can be more elaborate if we specify its direction of motion along with the speed. This is known as velocity. Velocity is defined as the rate of change of displacement. In all cases where displacement is zero, velocity of the body is also zero. A body moves along a straight line path at a constant speed. It is said to have uniform velocity. A body is said to have non-uniform velocity if its speed or direction changes with time. The average velocity is calculated by the arithmetic mean of initial velocity and final velocity. Average velocity is equal to initial velocity plus final velocity by 2. Initial velocity is denoted by u and final velocity by v. In uniform motion, the velocity remains constant. In a non-uniform motion, velocity varies with time. This change of velocities can be measured with a physical quantity called acceleration. Acceleration is calculated by the formula change in velocity by time taken. Change in velocity we can calculate v minus u. That is difference between final velocity and initial velocity. So we can define acceleration as rate of change of velocity. When a body starts from rest, it accelerates so that its velocity increases. In such a situation, final velocity is greater than the initial velocity. So the change in velocity is positive and the motion is in the direction of velocity. When the body stops at rest, it accelerates so that its velocity decreases. Here, the initial velocity is greater than the final velocity. Change in velocity is a negative quantity and the motion is in the opposite direction to that of the velocity. So this negative acceleration is known as retardation or deceleration. So the unit of this acceleration is meter per second square. Either it is acceleration or deceleration. We can calculate using the formula A is equal to v minus u by t. That is change in velocity by time taken. In a nutshell, the key terms we have learned today is motion, distance, displacement, speed, velocity and acceleration. Dear students, stay home, stay safe.